The most dangerous part of a heat wave is at noon? Wrong. It's around 3 a.m. Usually during a hot spell, temperatures drop right after dark. Our body takes a few hours to recover from it. But what if the temperature never falls below 80 degrees even during the night? The heat just keeps accumulating and it can't shed. Eventually, something gives. And that's exactly what's happening under a heat dome. It's a ridge of high pressure parked over a hot air mass and acts like a lid. Right now, it's sitting over the eastern two-thirds of the United States, and it's not moving. How does it work? The sun bakes the ground during the day. The ground radiates heat back up at night. The lid holds. Nowadays, Washington, D.C. is approaching its all-time record high of 106 degrees. Baltimore is closing in on 107, and the humidity makes it worse than any number suggests. We as humans can use our one and only cooling system, and it's sweating. While it works perfectly fine in dry heat, it barely works at all in humid air. In those conditions, sweat can't evaporate fast enough and the entire cooling system fails. Our core temperature rises. At some point, it'll start shutting down organs one by one. This specific point where heat plus humidity becomes physically unsurvivable even in the shade is called wet bulb temperature. Let's make it clear, we're not in it yet, but some areas of the US are getting close enough that the actual margin is a question of hours. And this is exactly why the heat kills more Americans every year than tornadoes or lightning strikes combined. Mainly because the threat is invisible. People basically underestimate it, and by the time the body is in real trouble, the window to fix it is already closing. Now it's getting stranger. At the same time, the western states are running 20 to 35 degrees below seasonal average. Two completely different summers happening at the same time, separated by a few hundred miles. Same weather system, but a complete opposite effect. One thing is clear. A summer like this used to be rare, but nowadays, it's starting to feel like a preview.
Western Europe is in the middle of a record-breaking heat wave. Some places have reached 111 degrees Fahrenheit. 6 countries have issued their highest-level heat warnings. People are losing their lives, and the reason might be more complicated than anyone could expect. France put most of the country under a red alert. The country's average temperature reached 86 degrees Fahrenheit. Not so extreme, but it's the average across the entire country day and night. In some places, temperatures climbed to 109 degrees Fahrenheit. It got so hot that 2 of Paris's most famous landmarks, the Louvre Museum and the Eiffel Tower, had to close earlier than usual. The buildings simply aren't designed to handle that kind of heat. More than half of France is under the highest heat warning. Tens of thousands of homes lost electricity. There's a massive risk of wildfires, and firefighters are already battling devastating forest fires. Since the heat wave began, at least 40 people have lost their lives in heat-related incidents. The rest of Europe isn't faring much better. The United Kingdom recorded one of its hottest Junes ever. Forecasters say that temperatures in certain places could reach 100 degrees Fahrenheit. Some cities have closed schools because classrooms became too hot. Power systems are struggling to keep up with all air conditioners and fans. Hospitals are treating more and more people with heat-related issues. Spain saw its highest average daily temperature since 1950. In May alone, 101 people in the country lost their lives because of heat. That's more than ever before for that month. Italy faces the same problem. Much of the country sits under the highest heat warning. The heat dries out the land. Some parts of Germany worry about drought. Local authorities have asked people to save water because supplies might run out quickly if the hot weather continues. The danger doesn't stop there. Dry grass and forests can catch fire much more easily during a heat wave. Some German cities have already banned barbecues to lower the risk of starting wildfires. The Netherlands has also warned people to prepare. Weather officials issued an orange alert. This means dangerous weather is likely to arrive. temperatures could climb to 102 degrees Fahrenheit. Belgium faces almost the same forecast. Much of the country remains under an orange heat alert, with temperatures potentially reaching 99 degrees Fahrenheit. Scientists have warned about this for decades. As more greenhouse gases build up in the atmosphere, they trap more of the sun's heat, like adding another blanket around Earth. The extra heat has to go somewhere, and Europe has become one of the fastest warming places on the planet. In fact, on average, Europe is warming about twice as fast as the rest of the world. That means heat waves like this will become more common. They'll last longer and reach even higher temperatures. You might be wondering why this keeps happening to Europe. You'd think every part of the planet would warm at about the same speed. Instead, Europe is warming faster than any other continent on Earth. The whole planet is now about 2.5 degrees warmer than it was before people started burning huge amounts of coal, oil, and gas. Meanwhile, Europe has warmed by about 4.3 degrees Fahrenheit. Part of the answer is surprisingly simple. Europe has a lot more land than ocean, and land heats up much faster than water. When you walk barefoot on a beach during summer, the sand burns your feet, while the ocean right next to it still feels cool. Water can soak up a huge amount of heat without getting really hot. Land can't. Europe also stretches far into the Arctic, and the Arctic is changing incredibly fast. Snow and ice normally act like giant mirrors. They bounce a lot of the sun's energy back into space. But as temperatures rise, that snow and ice melt away. Underneath them, there's dark ground and dark ocean water. Those darker surfaces absorb much more sunlight, which creates even more warming. That extra heat melts even more ice, and this vicious cycle repeats again and again. There's another thing most people never think about. Europe has seriously cleaned up its air by cutting pollution from factories and power plants, and that's great news for people's lungs. But some of that pollution was kinda good. It reflected a bit of sunlight back into space. Now the air is cleaner and more sunlight reaches the ground. This effect isn't so powerful compared to greenhouse gases, but it adds even more warming. Besides, right now, a huge area of high pressure is sitting over Western Europe. Meteorologists call it a heat dome. Imagine putting a giant glass bowl upside down over a city on a sunny day. The hot air underneath can't escape very easily. At the same time, the high-pressure system pushes air downward. When you squeeze air into a smaller space, it gets hotter, like a bicycle pump gets warm when you use it. That high pressure also clears away clouds, so sunlight pours onto the ground from morning until evening. And then, there's one more piece to the puzzle. Recently, winds have been pulling even hotter air north from the Sahara Desert. Then the heat dome trapped that air over Europe, so the continent ended up with the worst possible combination. Hot air from Africa, non-stop sunshine, and a giant lid in the atmosphere keeping all that heat locked in place. We should expect the next 5 years to break even more heat records. What used to count as an extreme heat wave is starting to become a normal summer. Are Europe's cities ready for this? That's a big problem. Heat takes the lives of more people in Europe than floods, wildfires, or storms. The World Health Organization states that every year, more than 175,000 people across Europe pass away from heat-related causes. Yet, authorities still don't treat extreme heat waves like other natural disasters. They often react only after temperatures become dangerous. Unlike hurricanes or floods, many countries still don't have a clear long-term plan for dealing with heat. Luckily, it's changing. Last year, the United Nations worked out a new global plan that might help countries prepare for extreme heat. The main goal is to treat heat waves as a real disaster instead of just another hot summer day. But fixing the cities themselves is much harder. Europe spent centuries building roads, homes, and public spaces for a cooler climate. Some streets were laid out long before cars even existed. Nobody back then expected summers with temperatures above 104 degrees Fahrenheit, so nobody designed cities to handle them. So now they're filled up with dark roofs, brick buildings, concrete, and asphalt. All of those materials act like giant sponges for heat. They soak up sunlight all day, then slowly give that heat back after the sun goes down. That's why walking through the middle of a city on a hot evening can actually feel worse than standing in the countryside at the same time. Even after sunset, the heat has nowhere to go. In many places, downtown areas stay up to 7 degrees hotter than the neighborhoods around them. To deal with this issue, Paris wants to plant about 170,000 trees. It'll help create more shade. Marseille is ripping out pavement in some old public squares and replacing it with plants and grass. Other cities are painting streets with lighter colors, so they reflect more sunlight instead of soaking it up. Some are changing building rules so new homes stay cooler and don't depend so much on air conditioning. But so far, it's a bit like putting a bandage on a broken leg. The real problem hasn't gone away. Europe still burns huge amounts of oil, gas, and coal every day. Cars, airplanes, factories, and power plants keep sending greenhouse gases into the atmosphere. On average, one person in the European Union is responsible for about 10 tons of greenhouse gases every year, while the global average is only about 5.5 tons. In many cases, it's still cheaper to fly than to take a train. Cities still don't have enough cooling centers where people can escape the dangerous heat. Many new buildings could become unbearably hot in just a few decades. And many older people who live alone still don't get regular check-ins during heat waves, even though they're the most likely to pass away from them. The European Union plans to roll out a new climate strategy by the end of 2026. It's supposed to help countries prepare for more extreme weather. Alarmingly, the weather is changing much faster than Europe is, and every summer, that gap gets a bit bigger. A solar storm is crashing into Earth like a cosmic tsunami. First, the atmosphere ignites, sparking massive auroras. High-energy radiation slams into the surface, frying power grids, turning lights off across continents, and knocking out satellites. Planes lose navigation, radios go silent, GPS systems crash, radiation levels spike dangerously. Communication collapses, emergency services scramble in the darkness, and chaos spreads as people struggle to cope. Solar particles start to strip away the very air we breathe, slowly peeling off our atmosphere. Soon, Earth will become a harsh and hostile place. That's what solar activity can do to our planet and its inhabitants if we didn't have a protective shield called the magnetosphere. But even with this barrier, we're still in for serious problems. A mysterious 100-year solar cycle may have just restarted, and it could mean decades of dangerous space weather. New research suggests that the unexpected intensity of the ongoing solar maximum may be partly tied to a lesser-known 100-year solar cycle. If the Sun is indeed entering its villain arc, solar activity could spike even further in the coming decades. It means more solar flares, more chances of them messing with the northern lights people keep posting on Instagram. Sure, not everyone's buying it. Some space nerds want more proof before jumping on this solar hype train. Let's break it all down into detail first. The Sun goes through a kind of mood swing every 11 years. This is called the solar cycle. It starts off at a solar minimum, which is pretty chill, then slowly gets rowdy. We're talking sunspots, solar flares, and other fiery drama. Once we reach solar maximum, the situation starts to calm down again. The Sun gets sunspots, dark patches on its surface, like the freckles we humans have, when its magnetic field starts flipping out. Literally, the Sun's magnetic field completely flips during peak solar drama. Scientists track how many of these spots show up to measure how spicy the sun is getting. But wait, plot twist, there are other cycles too, like the Hale cycle, which occurs around every 22 years. This cycle controls how magnetic fields move across the sun. Plus, way back in history, there were moments when the sun basically went on Do Not Disturb mode. During the Maunder minimum, our star was basically in sleep mode for 70 years. In other words, the sun might be entering a new extra phase, and things could get dramatic. On the bright side, that means more auroras. At the same time, it could also cause issues for satellites, GPS, and other stuff we rely on. Ugh, let's just hope it doesn't mess with YouTube. This extra phase is called the Centennial Gleisberg cycle. It's basically the sun's once every 100 years I do something weird moment. Scientists think it messes with how intense sunspot cycles get. No one has fully worked out how this cycle works yet, but some low-key sloshing of magnetic fields inside the sun might be causing it. Yep, I did say sloshing, like a giant cosmic smoothie. A recent study from March 2025 claims that the CGC might have just hit restart. That could explain why this current solar maximum, the sun's drama phase that started in early 2024, is being so weird and unpredictable. How did researchers figure this out? They looked at something called proton flux. Basically, it's how many positively charged particles are flying around in Earth's radiation belt. There are 2 of these belts, shaped like donuts that wrap around Earth, full of particles from the sun. The thing is, when the sun is active, our upper atmosphere swells, which makes the inner radiation belt lose some of those protons. And when the sun is chill, proton numbers go up again. So those protons have been increasing for like 20 years, but just started to drop in the past year. Which basically screams, CGC has just hit minimum. Time for the sun to crank it back up. The data came from NOAA satellites that flew through the South Atlantic anomaly, which is like the Bermuda Triangle of space. It's this bizarre zone over South America where Earth's magnetic field is weaker and space radiation gets closer to Earth. This area is perfect for observing proton activity without sending a satellite into the actual danger zone. So, right now, we're probably nearing the end of the sun's current chaos phase, aka the peak of solar cycle 25. Back in May 2024, it hit us with one of the craziest geomagnetic storms in 500 years or so. And yes, that means super bright auroras lighting up skies all over the world, even in places that usually only get clouds and vibes. But the scariest thing? This wasn't supposed to happen. During the last cycle, the sun was oddly calm. So NASA and NOAA looked at that and thought that the next solar cycle would probably be the same, no biggie. Well, they were wrong, and they even admitted it. Now, scientists think that SC24's quiet phase was because of the Centennial Gleisberg cycle being at its low point. That probably made it the quietest sunspot cycle in 100 years. So now that SC25 is lit again, pretty literally, it might just mean the sun is back to doing what it normally does, being a little chaotic and wild. Recent studies think the CGC minimum is finally over. That would explain why the current solar activity is turning up the heat, and why the last one felt like a cosmic snooze. An even cooler thing is that a 2024 study used AI to analyze sunspot patterns and found that CGC might be messing with our forecasts more than we thought. And if this long-term mood swing of our star is really back on the rise, future solar cycles could be just as wild as the one we're in now, or even wilder. After all, we've just passed the CGC's low-energy mode, and we won't hit the next maximum for another 40 to 50 years. Around solar cycle 28. That's a few decades away, but the sun's already throwing tantrums. The scariest part is that future solar activity might be twice as intense as what we're seeing now. You might be wondering right now, why should I care? Well, because when the sun freaks out, it messes with our stuff, especially in space. Satellites get dragged out of orbit because Earth's upper atmosphere literally puffs up like a marshmallow in a microwave when solar activity spikes. And this has already happened to a few spacecraft recently. And with tons of private satellite mega constellations like Starlink and its squad, the risk goes way up. There are some, even though those are few, that might not be ready for a full-blown sun rage event. Time to wear SPF 100 for your satellites. Astronauts are also at risk. More solar flares mean more radiation and more danger for humans in orbit. At the same time, more space tourists and missions mean more people potentially in the sun's cosmic splash zone. At the same time, not everyone is buying into the whole CGC is back and ready to party theory. Some experts say it's a cool theory, but we shouldn't get carried away. The thing is, the proton flux, those space particles we've been watching, only started dropping last year. That's not a lot of time. It might just be a short-term dip, like the sun sneezed and now everyone's freaking out. Also, we've only been able to track this stuff properly for 30 to 40 years or so, which is basically nothing in sun time. So there's no solid before and after data to compare CGC cycles and say, yep, this is definitely a pattern. Plus, the CGC itself is kinda mysterious. Like no one can fully agree on what it even is, how it works, or how much it actually messes with sunspot cycles. It's like the Bigfoot of solar science, blurry, weird, and causing drama in group chats. But even skeptics admit that the new study is interesting and well-intentioned, and that it might help us predict future solar cycles better. We just need more time, more data, and better definition of the CGC before we treat it like the ultimate weather app for the sun.
The scariest legend from Norse mythology, Ragnarok, could have been inspired by true events. Yeah, that story where Thor and the other deities go down fighting and the whole world ends, only to start later again. Around the mid-6th century of the current era, two massive volcanic eruptions took place on the American continent. These eruptions sent huge amounts of gas and sulfur dioxide into the air, which made the climate much colder across the northern hemisphere, including Denmark. In old records from China during those times, they wrote the sun got dim and cold like the moon. Grain crops couldn't ripen properly, and stars were hidden for over a year because of the volcanic particles that still lingered in the sky. Scientists wanted to understand how this colder weather affected trees, so they studied the growth rings of Danish oak trees from around that time. They wanted to see how the shift in weather patterns affected tree growth during this period. The scientists compared tree samples from Denmark with ice core samples from Greenland. These ice cores hold layers of snow and ice that trap tiny bits of sulfur and other particles from past volcanic eruptions, so they can show when these eruptions occurred. The tree rings show that the trees grew less than normal in the middle of the 6th century, so the weather was much colder than usual, probably because of volcanic ash in the sky. Some farms were abandoned during that time, and nature began to reclaim these areas. All this may have caused big shifts in society, like changes in village structure and ritual practices. Archaeologists have also found many valuable objects buried during that time. It looks like people were trying to offer them to deities to bring back the sun. They feared that an endless winter before Ragnarok would start if they didn't do something. A long time before that, in what is now England, people were busy building Stonehenge. There's no debate that the larger stones were brought there by humans, but there's a new theory about the smaller so-called blue stones. They don't seem so blue on a sunny day, but they do have a bluish tinge when rain falls on them or you break them, so be careful. So the main theory is that our Neolithic ancestors worked hard to bring the stones from the Preseli Hills to Salisbury Plain. A new study suggests that long ago, during the Ice Age, glaciers might have used the Bristol Channel as a highway to move rocks. They found a large, unusual rock called a glacial erratic in Limeslade Bay. A glacial erratic is a rock or boulder moved from its original home by a glacier to a new place. The rock in Limeslade Bay is made of a type of stone called dolerite, which isn't found in the Bay Area. but it matches rocks from North Pembrokeshire, which means it likely traveled by glacier to its new location. A massive glacier from the Irish Sea must have picked up this huge rock in Pembrokeshire and carried it southeast, then east, right up the Bristol Channel. They also found other glacial erratics along the Bristol Channel, which only supports this idea. So, if the new theory is correct, it means that Neolithic people didn't carry the bluestones to Salisbury Plain, but found them already there and decided to use them to build Stonehenge. Now, if you don't like shopping lists, try thinking of them as historical documents that someone will find, say, 3,500 years from now. Archaeologists in a region of Turkey that was known for the production of pottery, metal, and glass found one shopping list that was this old on a clay tablet. It's roughly the size of a large postage stamp and was made by people who lived in Mesopotamia. They used a very old type of writing called cuneiform, which means wedge-shaped, as it was made up of marks that looked like wedges. The language written on this tablet is called Akkadian, and it went extinct long ago. They used sounds to make words, just like we do today. To write these sounds, they borrowed symbols from an even older language called Sumerian. The tablet itself is a kind of shopping list left by people who were buying a large amount of furniture. They mention tables, chairs, and stools. This record helps us understand how people in the late Bronze Age kept track of goods, money, and trade. Looks like they had an organized system for buying and selling things. Meanwhile, the Bronze Age shopping list is a youngster compared to what is thought to be the oldest calendar in the world. It shows the fall and impact of a comet from around 13,000 years ago. The carving is part of the Göbekli Tepe temple complex in Turkey. Talk about alliteration. It has large round stone structures and pillars that are carved with pictures of animals and symbols. People in the Neolithic period, around 11,000 years ago, built the temple, and it might have been used for something like a giant observatory for watching the night sky. One of the most interesting objects at the complex is a tall carved vulture stone. This stone has the image of a bird and other designs on it. One scientist who studied it thought the designs might show constellations. The carvings could tell the story of a huge comet that changed the weather patterns on Earth and caused a mini ice age. There are small V-shaped marks on the pillars at Göbekli Tepe, which could be used for counting days, and other stones could show big celestial events, like meteors or comets passing by. Archaeologists in Italy, near the ancient city of Naples, were checking the ground to change the city's water pipes when they found a tomb that is about 2,000 years old. It had been well preserved, with paintings on the walls that show scenes from myths and ceilings that haven't faded. This tomb of Cerberus was named after the most famous painting you can find inside. Cerberus was a creature from Greek mythology, a huge, scary dog with 3 heads. He was known as the guard dog of the underworld. One famous myth you can see on the walls of the tomb is the story of Hercules capturing Cerberus as part of his 12 labors. As the archaeologists kept digging, they discovered images of ichthyocentaurs, creatures that were like a mix between a mermaid and a centaur. The tomb also has a large altar with vessels for liquids that they would pour out as an offering to honor the deities. The person who was buried here lies on a decorated burial bed, surrounded by paintings, symbols, and objects that people in ancient times believed would bring peace or help in the afterlife. The tomb was just found in October 2023 and is not open to visitors yet, as archaeologists are still studying it. Scientists have long wondered how heavy stone blocks were carried to the sites of the pyramids in Egypt, and they might finally have an answer. Researchers from the University of North Carolina, Wilmington, believe that the ancient Egyptians built 31 pyramids along an ancient branch of the River Nile. It's now hidden under desert and farmland. It's not a new idea, but up until recently, scientists weren't sure of the location, shape, size, or proximity of the waterway the pyramid builders could have used for transportation. This time, they used radar satellite imagery, historical maps, geophysical surveys, and sediment coring to map the river branch. A major drought and sandstorms likely buried it thousands of years ago. The team managed to go below the sand surface and get images of some hidden features thanks to radar technology. They found hidden rivers and ancient structures running at the foothills of where most of the ancient Egyptian pyramids lie. Thanks to this discovery, we can now understand why they decided to build so many pyramids between Giza and Lisht in what is now an inhospitable area of the Sahara Desert. Kilauea, one of the most active volcanoes in the world, erupted again in March 2026 on Hawaii's Big Island. Huge lava fountains shot into the sky. The main highway was closed, and the airport was blocked by sandpaper clouds of ash. The sky turned a creepy deep red. That's how thick the smoke was. The eruption literally closed some areas of the island. It was already the second time this year. The eruption happened right inside the Halemu'umu'u crater at the volcano summit. Things got dangerous fast, and visitors had to evacuate the volcano summit. The lava fountain shot straight up about 1,300 feet. That's almost as tall as the Empire State Building or higher than the Eiffel Tower. But let's watch the eruption unfold step by step. It started on March 10, 2026, and lasted about 9 hours, ending suddenly at 6:21 p.m. The eruption started in the morning at 9:17, with lava shooting up from the north vent. As for the south vent, it started erupting just before 10 a.m. By early afternoon, the lava fountains were huge. The south vent reached 1,150 feet high, and the north vent was 1,000 feet. The lava was flowing across about 1/3 of the crater floor, glowing bright orange and red. As the lava cooled in the air, it turned into something called tephra. That's a mix of volcanic rock, ash, and tiny glassy shards. Tephra can scratch your skin like sandpaper, making your eyes sting and making it hard to breathe. Even worse, it can turn roads into skating rinks for cars. Because all of this, part of Highway 11 was closed between mile markers 24 and 40. Back in January, during another eruption, it also rained tephra over the park and nearby towns. Some unlucky visitors actually got hit by falling tephra, and a few even got cuts. The Park Service had to close the summit for the first time since its eruption cycle began on December 23, 2024. Now, the National Weather Service says the eruption plume reached 25,000 feet high. That's nearly 5 miles straight up, higher than most airplanes fly. Winds were blowing from the south, so ash and gas started moving north from Halemu'umu'u. Officials warned people in nearby cities to stay indoors or leave if the gases began to bother them. Now, this eruption wasn't the first trouble Kilauea caused this year. An earlier one started on February 15th and lasted almost 10 hours. During that eruption, lava covered half of the crater floor. Scientists estimate that 15 million cubic yards of lava came out. That's enough to fill thousands of swimming pools or cover hundreds of football fields. At 2 p.m. on March 10th, tephra was still falling. Park rangers helped evacuate visitors from the summit. All trails and viewing spots near the summit were closed. Scientists are keeping an eye on things all day and night, watching how high the lava shoots, how fast it flows, which way the ash cloud is moving, and where the fallout spreads. Even though the lava mostly stays in the crater, tephra and volcanic gases can make living near a volcano pretty risky. Since December 24, 2024, Kilauea has been spitting lava on and off, mostly from 2 vents at the summit crater, one to the north, one to the south. Eruptions happen in short bursts, usually less than half a day. After that, the volcano takes a break for a while. Could we say the volcano is chilling? No, we can't. Sometimes those pauses can last 2 weeks or more, as if giving the lava time to catch its breath before the next show. But let's talk a little bit more about tephra. The biggest problem is that it doesn't just stay near the volcano. In past eruptions, it rained down on neighborhoods as far away as Hilo and Puna, messing up water systems and creating a huge cleanup job. At Hilo International Airport, all evening flights were canceled because of ash in the air. And for weeks afterward, locals and park staff were sweeping tephra off roofs, gutters, streets, just about everywhere you can imagine. According to the park spokesman, the reason tephra spread so far is a mix of weak winds and extremely tall lava fountains. When that happens, the volcanic debris drops straight down over the park and nearby towns. During past eruptions, steady winds, called trade winds, which usually blow from east to west across the islands, acted like a conveyor belt. They carried ash and volcanic gases over the Cow Desert and nearby towns to the southwest. Another super dangerous thing about an eruption is glass rain, also called Pele's hair. It's a kind of tephra that happens especially when lava fountains shoot up really fast. Tiny gas bubbles in the lava burst and stretch the molten rock into super thin, fragile strands. The wind then carries them far away. This stuff is lightweight but brittle, so it can scratch your skin or get in your eyes or lungs. The name comes from Pele, the Hawaiian goddess of fire and volcanoes, because it's kind of born straight from volcanic activity. During big eruptions, like the one in 2018, these strands were reported falling all around the volcano. Now, Kilauea isn't the only threat in the region. The sleeping giant next door, Mauna Loa, got an update from scientists on March 5, 2016. The volcano isn't erupting yet, but it's inflating as magma fills its huge underground chambers. You might think of it like Earth taking a deep breath. But it isn't just breathing. In the past month alone, over 100 earthquakes have been detected under the summit. Should we get worried? Well, let's figure it out. Mauna Loa, the largest active volcano on Earth, covers half of Hawaii's Big Island. Its eruptions can produce huge, fast-moving rivers of lava, like a slow-mo bulldozer made of molten rock moving across the area. When Mauna Loa erupts, it usually starts at the summit. From there, lava can flow into different areas: the Northeast Rift Zone, Southwest Rift Zone, or even vents on the northwest side of the volcano. The most intriguing thing is that these lava flows can appear within minutes, hours, or even months after the eruption begins. Since its first well-recorded eruption in 1843, Mauna Loa has erupted 34 times. The gaps between eruptions can range from just months to many decades. Its most recent eruption was in 2022. Right now, Mauna Loa is quiet but active. Seismic activity, that is, small earthquakes under the volcano, shows that magma is, in fact, moving beneath the surface. In February 2026, scientists detected 116 earthquakes beneath the summit, mostly gathered under the caldera era called Makuaweo Veo. Some were also concentrated in the southern caldera. But don't let this number scare you. For comparison, the month before had 123 earthquakes. The thing is, these quakes are part of the normal breathing of the volcano as it refills with magma after the 2022 eruption. GPS instruments on the volcano indeed show that the summit is inflating, meaning the ground is slowly rising as magma fills the underground reservoir. At the same time, gas and temperature readings from the Southwest Rift Zone are at normal levels, which means no major changes compared to previous months. So even though Mauna Loa is refilling, there's no immediate sign of a new eruption, yet. In any case, Mauna Loa is always worth watching. It's a sleeping giant that can wake at any time, and scientists are keeping a close eye on every inch of rising ground. Because if Mauna Loa erupts, it can cause a ton of different problems. Massive rivers of lava can flow quickly and cover land in their path. The volcano itself can also make the ground shake, because as magma fills it, the sides of the mountain can shift up or sideways, triggering earthquakes. On top of that, Mauna Loa can release volcanic gases that mix with the air and create fog, a kind of smog that can be irritating or even make it hard to breathe for people living downwind. Sometimes, the volcano might even produce small explosions, sending ash into the sky, which can be dangerous for airplanes flying nearby. Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sundhnúkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. Let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches, and that's a carefully measured, long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. Engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean geoid low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. Our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan Traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean geoid low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine.
One of the biggest stars we've ever found is wobbling on the edge of disaster. And it won't go quietly. It might collapse in on itself and instantly become a black hole, or explode in a blinding supernova. It might even crash into its companion star, and we could probably see it. The star in question, WOH G64, wow, that's a mouthful, I'll nickname it Jerry. So Jerry is a red supergiant. These are huge stars at the end of their lives. Like cosmic seniors, they've already burned through most of their fuel, puffed up to an enormous size, and are getting ready to explode as a supernova. They're cooler on the outside than many other big stars, that's why they glow red instead of blue or white. Still, the biggest and brightest of these stars are kind of a mystery. Astronomers aren't totally sure what happens to the most extreme ones right before they explode. When they look at the sky, they don't see as many ultra-bright red supergiants blowing up as they would like to. Instead, they see hints that some of them might change color and heat up again before the end. One famous example is our star called WOH G64 in the Large Magellanic Cloud. That region is basically a stellar nursery. It means it's packed with thick clouds of gas and dust where stars are born. It's the perfect place to grow something extreme. Now, for decades, we considered Jerry one of the most outstanding red supergiants ever found. It's enormous, it's incredibly bright, like me, and losing mass like crazy. It's also surrounded by so much dust that it looks heavily wrapped up, like it's hiding inside a thick cosmic blanket. But recently, something weird happened. The star's light signature started to look completely different, as if this red supergiant had changed identity. Now scientists think Jerry isn't just a single star. It's probably a rare pair of stars locked together in a relationship called a symbiotic binary system. In this system, the red supergiant seems to have transformed into something hotter and more unstable, called a yellow hypergiant. Now, yellow hypergiants are like the middle phase before total destruction. They're enormous. Some are so big you could fit billions of suns inside them. But they don't last long. This stage is brief and chaotic, like a star pacing nervously before its final act. Yellow hypergiants are extremely rare because they represent a short transition between the red supergiant phase and the final explosion. We know of only a few dozen confirmed examples. Now, why would that transition happen? One possibility is stellar drama. Ooh, what could happen? Well, as we know, imagine two stars spinning around each other so tightly that one basically starts stealing material from the other. That lost material could have formed a massive cloud, a shared envelope that briefly swallowed both stars. But there's another possibility. Even without interference from a companion, a star this massive can become unstable on its own. It might have gone through a huge eruption that lasted more than 30 years and is now settling down into a hotter yellow phase. Whatever it is, this is incredibly rare, like watching a star evolve in real time instead of over millions of years. In any case, after watching this monster star suddenly change before their eyes, astronomers now think it may be getting close to the end. A new study claims the star could be on the verge of exploding in a massive supernova. Or, since it's so unbelievably heavy, it might skip this step completely and collapse straight into a black hole. Now, Jerry was discovered about 50 years ago and labeled a red supergiant. It has about 30 times the mass of our Sun. But the really mind-blowing part is its size. If you drop this star into the middle of our solar system, it would stretch all the way past Jupiter. Stars like this live fast but not long. Jerry is only about 5 million years old. That might sound ancient until you remember our Sun is 4.6 billion years old and still going. The problem is, massive stars burn through their fuel super fast. That's why they shine so bright, grow to ridiculous sizes, and then go out in a blaze of glory. Now, we don't know how it'll happen, but because of its enormous mass, Jerry's demise won't be quiet. In cosmic terms, it could happen soon, meaning within a few hundred to a few thousand years. It might explode in a supernova, blasting its outer layers into space. Or it could collapse inward so violently that it forms a black hole on the spot. There's even a chance it could eventually slam into its companion star. So let's say our red supergiant tears itself apart in a supernova. Then we need to learn more about these space fire shows. Supernovas are gigantic explosions that happen when massive stars finally collapse. They're incredibly important to how we understand the universe. Astronomers use certain types of supernovas, like measuring sticks, to figure out how far away galaxies are. In fact, it was supernovas that tipped scientists off in 1998 that the universe wasn't just expanding, it was actually speeding up. But there's one problem. Even though supernovas are powerful and bright, they happen incredibly fast. Catching the exact moment a star explodes is like trying to photograph a lightning bolt at the exact second it strikes. But an international team of astronomers says they managed to do exactly that. They got the earliest and most detailed look ever at a supernova right as it was blowing apart. Using the European Southern Observatory's Very Large Telescope, they basically watched the shockwave from the collapsing star blast through its surface. For the first time ever, they could actually see what shape the explosion had. And that shape does matter. When a massive star runs out of fuel, things go bad fast. For millions of years, the star balances two forces: the nuclear fusion in its core pushing outward and gravity pulling inward. But once the fuel is gone, gravity wins instantly. The outer layers crash inward, slam into the collapsed core, and rebound outward in an intense shockwave. That shockwave tears through the star and blows it to pieces. The result is a supernova. That's the basic idea. The details of how that shockwave forms have been hard to pin down, because supernovas are nearly impossible to catch in the act. Out of the trillions of stars out there, astronomers would need to be already looking at the exact right star at the exact right moment, and it would have to be close enough to study before expanding gas clouds block the view. This time, they got lucky. The explosion happened about 22 million light-years away, which also means it happened 22 million years ago. Think about that. Astronomers spotted it quickly and managed to start observing it within just 26 hours after it was first detected. In supernova terms, that's incredibly fast. They used a technique called spectropolarimetry, basically a way of studying how light is scattered and how its vibrations are aligned to figure out the shape of the blast. What they found was surprising. The explosion wasn't perfectly round. Instead of expanding like a smooth sphere, the shockwave stretched out slightly, more like an olive than a ball. When the blast slammed into the gas surrounding the star, it flattened, but it still expanded evenly along that stretched shape. It means the very first light and material didn't shoot out evenly in all directions. The explosion had structure right from the start, and that structure gives clues about what was happening deep inside the star when it collapsed. Now, here's another interesting fact. The star that went supernova was a red supergiant, about 12 to 15 times the mass of our Sun, rather than a perfect sphere. In other words, these cosmic explosions may be more organized than we thought. Around our planet, there's an invisible magnetic shield that blocks solar radiation. But it isn't spread evenly. One patch is thinner and it has a name, the South Atlantic Anomaly. On the ground, we're fine. Up in orbit, satellites get glitchy as they fly through charged particle storms. And lately, that weak spot looks like it's changing shape. It's spreading out, and some maps even show it splitting into two. So why is that happening and what does it mean? Well, to understand the weak spot, we have to go deep below to the core of the issue and the planet. Around 1,800 miles down, Earth's outer core is a boiling ocean of molten iron and nickel. There, the temperature can rise to more than 10,000 degrees Fahrenheit. As that liquid metal moves, it generates electric currents, and those currents create our magnetic field. Now, without the field, the sun's charged particles would slam straight into our atmosphere and start stripping it away. But this magnetic field isn't a smooth, perfect bubble. It's lopsided and tilted. It's constantly shifting. Beneath Africa, some magnetic lines bend the wrong way, back toward Earth instead of out into space. Scientists call these reverse flux patches, and they weaken the field above them. Right over that weak spot is the SAA, the South Atlantic Anomaly I mentioned earlier, and it's changing fast enough that we can watch it shift over just a decade. Scientists know this because of an ESA mission called SWARM. It's 3 satellites constantly, swarming, and mapping Earth's magnetic field in detail. Their maps show that the anomaly has been spreading since the mid-2010s. It's getting weaker and starting to look like it's splitting in two. Now, back down here, we're protected by the atmosphere, but we are still affected indirectly if satellites start acting weird. Most of the satellites we rely on are in low Earth orbit, a few hundred miles up. Over the SAA, the radiation belts droop closer to Earth than usual, so when a satellite passes through, it's like driving through a stretch of space that's far more charged than normal. A single burst of particles can flip tiny bits inside a computer chip. It can corrupt a sensor for a moment or trigger a reset. It can force the satellite into safe mode, where it shuts down anything sensitive to survive. Many satellites cross the SAA multiple times a day, which means each pass is another roll of the dice. Even Hubble has to respect it. Hubble is one of the most famous space telescopes that's been taking those insanely sharp pictures of galaxies, nebula, and weird deep space stuff for decades. But when it's about to fly through the South Atlantic Anomaly, it basically goes, no. It stops certain observations and shuts down its most sensitive detectors until it's in the clear again. The satellite is too valuable, and it's not worth taking chances and losing it. Which is exactly what happened to a high-tech Japanese satellite. In 2016, Japan launched Hitomi, a next-gen X-ray space telescope built to study the hottest and craziest objects in the universe, stuff like exploding stars and monster black holes. It was supposed to run for years. Instead, a problem that showed up when it was passing through the SAA kicked off a cascade of attitude control failures. The spacecraft ended up spinning, breaking apart, and the whole mission was lost just weeks after launch. That's not a glitch. That's a multi-year science plan worth billions of dollars lost in just a month. So why does SAA seem to be growing, and why would it split into two? Deep under Africa, Earth's core is like a giant pot of liquid metal. The swirls can change shape over time. Imagine you're holding a strong magnet under a table, and on top of the table there's a thin metal sheet. If you slide the magnet around underneath, the metal above shifts too. If you use one magnet, you get one dent. If you move it or add another magnet nearby, the dent stretches or splits into two. The moving liquid iron deep below acts like shifting magnets. When the flow pattern changes, it creates weak spots in the magnetic field. If one weak spot spreads underground, the dip above it spreads too. If two weak spots form close to each other, that single sag at the surface can split into two dents right next to each other. And that's where this stops being cool Earth science and starts being a problem. Because if the magnetic field can rearrange itself that much in a decade, well, anything we rely on in orbit has to deal with it. But is the South Atlantic anomaly just one local weak spot we have to work around? Or could it be an early hint of something much bigger, like a pole reversal? You see, Earth's magnetic poles are not locked in place forever. North and South have swapped many times before. Magnetic North can drift, weaken, and eventually trade places with magnetic South. Wait, what does that actually mean? Well, it means those football fans who are gathering in the North Stand now have to start cheering from across. But, jokes aside, the planet is not flipping around or becoming the upside-down world. The liquid iron shifts its flow pattern, and the whole magnetic layout reshuffles. Just like every other natural process, it doesn't happen all of a sudden. The field can weaken first, it can break into uneven patches, it can look messy for a while before it settles again. That problematic stage is what would matter most for satellites. Because we know this happened before. When hot lava cools into rock, tiny bits of metal inside line up with Earth's magnetic field and get stuck pointing that same way. Much later, scientists can read that direction like a compass arrow trapped in stone. One famous case is the Lachamps event about 41,000 years ago. Hey, I wasn't around then. But for a while, Earth's magnetic field got much weaker. Then it partly flipped, and then it bounced back. The simplest idea is that the liquid iron deep inside Earth started flowing in a different, unpredictable way for a while. So the magnetic field got scrambled. A pole reversal is the biggest version of this scramble. The South Atlantic anomaly is a smaller local version. Both happen because the liquid iron flow deep inside can change. The SAA does not mean a reversal is definitely coming. It just shows the magnetic field can get uneven when the stuff underneath shifts. While the anomaly is changing, there's another space problem that can hit way beyond that one spot in the Atlantic: geomagnetic storms. The Sun sometimes launches a huge cloud of superhot gas with its own magnetic field. It's called a coronal mass ejection, or CME. Some of these clouds race outward at over 1 million miles per hour. If one of them is aimed at Earth, it slams into our magnetic shield and shakes it. That shaking dumps extra energy into the space around Earth. It scrambles radio signals, messes with GPS accuracy for a while, and, in extreme cases, even pushes electric currents into long power lines on the ground. Oh, and they also cause breathtaking auroras. Back in March 1989, a major geomagnetic storm triggered a Quebec blackout that left 6 million people in the dark for hours. Another example was in May 2024, when a strong geomagnetic storm disrupted certain satellite and radio signals, forced some airlines to adjust routes, and pushed auroras much farther south than usual. Solar storms don't hit at the same strength all the time. The Sun goes through an activity cycle that lasts about 11 years. During the busiest phase, it fires off more flares and more giant clouds of charged particles, so strong geomagnetic storms become more likely. Right now, we're in one of those busier stretches. So the odds of rough space weather are higher than they were a few years ago. But the bigger reason it feels scarier is how modern life works. We lean on satellites and power grids more than ever. So a storm that used to be a cool aurora night can now mean signal glitches, GPS hiccups, rerouted flights, grid strain, and a lot of expensive fixing.
Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The US East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the US East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe
we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100.
Hey, want to take a wild trip back in time to the Jurassic or Cambrian era? Trust me, it's going to be a wild ride, but surviving in those ancient environments would require some serious skills. At the start of the Cambrian era, the air would be as thin as at the base camp of Mount Everest, but the climate was actually pretty chill and consistent back then. However, there was one teeny tiny problem: no land plants or animals to feast on. So forget about firing up the grill for a juicy steak. Instead, you'd have to come up with creative ways to catch trilobites and other funky-looking shellfish. Good luck finding a spear without any wood or a fishing net without any plant fibers. And get ready to eat them raw, unless you can figure out how to extract oil from these creatures or burn dry seaweed. But wait, if you're looking for a more comfortable existence, you gotta travel to 100 million years ago, to the Silurian period. Here, things start to get a bit easier. The air is still thin, but there's a bit more oxygen to go around. Plus, the climate is warmer and cozier. Simple land plants have finally made their debut. Not only that, but the first bony fish also show up on the scene, so you might actually find something more palatable to munch on. Just watch out for those prehistoric millipedes and spider-like creatures that share the land with you. They might not be the best dinner companions. Yeah, it all sounds fun and feasible, but let's talk a bit more about this crazy idea of instant transportation. If you magically appeared in a different time, the first thing you'd have to worry about is the amount of oxygen in the air. Now, looking at that fancy graph up there, it's pretty clear that oxygen levels used to be super low before about 0.85 billion years ago. Like, we're talking just a few % of the atmosphere. And there wasn't even any O2 in the air until this event called the Great Oxygenation happened about 2.3 billion years ago. So if you ended up back then, surviving would totally depend on how fit you are. If the oxygen concentration was less than 10%, you'd probably pass out, but not pass away. If it was just above 10%, you might be able to function, but you wouldn't exactly be living your best life. Based on oxygen alone, it seems like you could survive if you showed up around 0.75 billion years ago, give or take a few million years. Now let's talk about the cool stuff on land. The first land plants didn't show up until around 450 million years ago during the Ordovician period. Before that, there were some large algae hanging around, mostly in the range of 500 to 600 million years ago. But there wasn't a whole lot going on until those land plants came along. Other forms of life didn't start showing up on land until closer to 300 to 400 million years ago. But there was this critter, a myriapod, that lived around 428 million years ago, and it was one of the earliest land dwellers. I mean, if you lived back then, you'd have to come up with fancy recipes featuring myriapods. Not exactly mouth-watering. Don't worry if you find yourself back in time before all that land action. Around 500 to 600 million years ago, the oceans were teeming with life. There were these creatures called the Edicarian fauna, and they were some of the first well-preserved organisms. Some of them probably hung out in the shallow areas near the shore, so you might be able to get your hands on them for a meal. But remember, there weren't any land plants yet, so you'd probably have to eat them raw and with no potatoes on the side. You'd have a sort of prehistoric sashimi on your plate. Now, around 500 million years ago, things started to get really interesting in the oceans after something called the Cambrian explosion. If you ended up in the Cambrian period, you'd have all sorts of weird animals to catch in the coastal zones. Check out the fossils from the Burgess Shale for some wild ideas. Look at these brachiopods, arthropods, and even worm-like critters. But again, no woody land plants at this point, so your meals would mostly consist of raw arthropods and algae. Alrighty, let's dive into the nitty-gritty of ice ages. It's when the Earth gets super chilly for a ridiculously long time, like millions and millions of years. This causes giant ice sheets and glaciers to spread all over the place, covering massive areas of the planet's surface. Believe it or not, our planet has experienced at least 5 major ice ages. The very first one happened about 2 billion years ago and lasted for 300 million years. The most recent ice age kicked off at around 2.6 million years ago, and we're technically still in it. So, we're in the middle of an ice age, but we're not currently living in an icy wonderland. That's because we're currently in an interglacial period. During an ice age, temperatures go through ups and downs. When it's warmer, those ice sheets and glaciers start to melt, creating what we call interglacials. And when it gets colder, they expand again, which we call glacials. So right now, we're enjoying the warm interglacial period of the most recent ice age, which kicked off around 11,000 years ago. When people mention the Ice Age, they're usually talking about the last glacial period that started around 115,000 years ago and ended roughly 11,000 years ago when our current interglacial period began. During that glacial period, things were way cooler than they are now. At its peak, when ice sheets covered most of North America, the average global temperature was about 46 degrees Fahrenheit. That's a whole 11 degrees Fahrenheit cooler than today's global average temperature. That temperature difference may not seem like much, but it was enough to turn most of North America and Eurasia into ice-covered landscapes. The Earth was also a lot drier, and sea levels were way lower because most of the water was trapped in those ice sheets. We're talking vast steppes, dry, grassy plains as far as the eye can see. And let's not forget about the savannas, warm, grassy plains, and deserts that were also part of the icy scene. During the Ice Age, there were some familiar critters roaming around, like brown bears, caribou, and wolves. But there were also some mega cool creatures that sadly went extinct when the Ice Age came to an end. We're talking mammoths, mastodons, saber-toothed cats, and giant ground sloths. Now, there are a bunch of theories floating around about why these magnificent beasts bit the dust. One idea is that us humans hunted them into extinction when we crossed paths with these megafauna. Our species, Homo sapiens, actually survived the Ice Age. We've been kicking it on this planet for around 300,000 years now, starting out in Africa and then spreading our awesomeness all over the globe. Some of our ancestors stayed put in Africa and didn't experience the full icy effects. Others ventured into different parts of the world, even braving the freezing cold of Europe's glacial environments. But we weren't the only ones out there. At the beginning of the Ice Age, there were other hominids, our closer relatives, scattered across Eurasia. We had the Neanderthals chilling in Europe, and the mysterious Denisovans hanging out in Asia. Sadly, both of these groups seems to have vanished before the Ice Age wrapped up. Now, there are countless theories about how our species managed to survive the Ice Age while our hominin buddies didn't make it. Some believe it's because we're ridiculously adaptable and used our social skills, communication, and nifty tools to our advantage. And get this, humans didn't just hunker down during the Ice Age. Nope, we explored new territories and made ourselves at home. For the longest time, folks thought humans didn't set foot in North America until after the ice sheets started melting. Fossilized footprints discovered at White Sands National Park in New Mexico prove that humans have been rocking it in North America for at least 23,000 years, right around the peak of the last ice age.
Did you know that the Pleistocene era was a really important time in Earth's history? It's when the last ice age happened, and glaciers covered a lot of the planet. This period of time lasted for about 2.6 million years, and ended around 11,700 years ago. What's even cooler is that modern humans, like us, had actually evolved during this time and had spread all over Earth before it ended. There were also some really fascinating animals that lived during the Pleistocene, like woolly mammoths and saber-toothed cats. Unfortunately, many of them went extinct at the end of this era. Earth has had some pretty wild weather patterns over the last 2.4 billion years. Although the planet is mostly ice-free, we now cycle in and out of freezing ice ages. During these glacial periods, temperatures drop and huge areas of the planet get covered in ice. It all starts with a bit of snow, which then builds up over time. The ice reflects sunlight, making things even cooler. The result? Vast glaciers that slowly move toward the equator, changing the landscape as they go. And when the ice melts, sea levels rise again, and everything changes all over again. In total, there have been at least 5 ice ages so far. The first one was so intense that the whole planet turned into a huge snowball. Right now, we're actually in the middle of an ice age, but we're currently in a temporary warm spell that started around 11,000 years ago. These warm periods are called interglacials, and we're not quite sure how long they last. There are still massive ice sheets covering Antarctica and Greenland that hold 75% of Earth's fresh water. When these finally melt, it'll mark the end of the current ice age. Earth's temperature is affected by something called the Milankovitch cycles. Basically, the amount of heat we receive from the sun changes over years, decades, and millennia because of Earth's orbit, tilt, and axis angle. There are 3 different patterns to these cycles. The first is called eccentricity, which is all about the shape of our orbit. The second is obliquity, which has to do with the tilt of the Earth. And the third is precession, which is like a wobble as Earth spins. Depending on where we are in these cycles, we might experience colder or warmer temperatures. But other things, like the position of continents and the atmosphere, also play a role in our planet's fate. For example, our planet's orbit is not quite circular. It's actually a bit elongated, shaped almost like an egg. That means we're sometimes a little closer or farther from the sun, depending on the time of year. We call the point farthest away from the sun the apogee, and the closest point is the perigee. When we're at the apogee, we're moving away from the sun, but gravity eventually pulls us back toward it. This means our orbit changes a little each time, gradually shifting our position relative to the sun. Don't worry, even though the orbit changes over thousands of years, it doesn't have a big impact on our day-to-day lives. Changes in Earth's orbit can affect how much sunlight we get during the summer. This means that ice sheets in the northern hemisphere will melt less, and over time, they actually start to grow. As they grow, they reflect even more sunlight, which makes the climate even cooler and spreads the ice even farther. This process can last for a really long time, like 10,000 to 20,000 years, and eventually it brings the planet into its next freezing season. As for the next ice age, scientists believe it might be postponed indefinitely. They've found that our human interaction with the environment, like the use of fuels, could delay the next ice age by up to 100,000 years. Earth's past ice ages were linked to the amount of solar radiation and carbon dioxide concentration in the atmosphere, and this research can even help us predict future cycles. It's amazing to think that our actions now could affect Earth's future for thousands of years to come. And while it's not really important when the next ice age begins, it's pretty cool to know that humans have the power to shape the future on a geological timescale. Ice ages have had a huge impact on our planet and human civilization. So it's fascinating to think how our actions now might change things, maybe even for the better. What did life look like on our planet during the last ice age, though? Well, North America, for instance, was home to some huge creatures. Mammoths, saber-toothed cats, giant ground sloths, and mastodons were just a few of them. And get this, even Europe had an 11-foot tall flightless bird that weighed almost as much as a polar bear. Meanwhile, down under in Australia, there was a giant lizard that lived in all sorts of habitats during the same time period. Even though some animals from the Pleistocene era aren't around anymore, you might recognize many of those that are still around today. In Alaska, for example, you can still find brown bears, caribou, and wolves. People just like us actually lived through the Ice Age too. Our species, Homo sapiens, has been around for about 300,000 years. And we've spread all around the world since then. Some of our ancestors stayed in Africa during the Ice Age and didn't feel the full effects of the cold. And others ventured out into other parts of the world, even into the chilly glacial environments of Europe. Our early relatives, like the Neanderthals in Europe, and the mysterious Denisovians in Asia, were also around during this time. Although they seem to have gone extinct before the end of the Ice Age, it's pretty amazing to think about all those different hominids that roamed Earth during that period. What's also fascinating is how our species managed to survive the Ice Age, while some of our cousins didn't. Some experts believe that our adaptability, social and communication skills, and the use of tools played a huge role in it. And guess what? Humans didn't just hunker down during that time. We actually moved into new areas. Fossilized footprints found at White Sands National Park in New Mexico prove that humans have been in North America since at least 23,000 years ago. That's close to the peak of the last Ice Age. While a full-blown Ice Age might still be far away, there is a possibility of a mini Ice Age coming our way. Some scientists believe that in about 10 years, we might experience a significant drop in solar activity, leading to colder temperatures in the northern hemisphere. This could result in conditions similar to the Little Ice Age in the late 17th century, when the Thames River in the UK froze over. While scientists aren't quite sure what caused that cooling, it's fascinating to think about the potential changes. We've done it before, so we know that humans will most likely survive the next real Ice Age, even if we don't manage to figure out a way to stop the next freezing era. But it would come at a high cost. All the ice that would cover most of the northern hemisphere would have to come from oceans, which would cause the sea level to drop. This could mean more land for some countries, but it would also create other problems. Sea levels going down might seem like a great thing at first, but actually, it could lead to some challenges. Having been covered with salt water for thousands of years, the new land might not be very fertile. This means it wouldn't be great for growing crops, and we'd have to find other ways to feed ourselves. Back when humans first started out, there weren't many of us, and there was plenty of food. Now, with over 7 billion people on the planet, it's a different story. We'll need to be resourceful to make sure everyone has enough food to eat.
See this big spot under the water near the shore? It's a coral reef. It beckons you to swim closer, but be careful. If you get there, it could be the last swim of your life. Stay away from the reef. But why? Why are coral reefs so dangerous? Let's figure it out. First, make your guess about what a coral reef is. An underwater cliff? Rocks? A coastal landscape? Some spot where shells live? Close, but not true. In short, a coral reef is a living thing. What we see in shallow tropical waters are colonies of organisms called coral polyps. They are distant relatives of jellyfish and anemones with amazing superpowers. They can absorb calcium from the water. When they do this, they convert calcium into hard limestone rocks. These rocks, like building blocks, form solid coral reefs and settle on the seabed. But there are soft coral reefs that look like plants. They float freely with the currents, swing in different directions, and seem to pulsate under the water. They don't have solid coral blocks, but they can grow tree-like cores to maintain their position. Both hard and soft coral reefs are beautiful creatures, but at the same time, they are very dangerous. Many ships were wrecked when they hit shallow water, as the sharp edges of coral reefs ripped through their hulls. But what danger is there for someone swimming alone, who isn't going to hit the reef? You can just scuba dive and enjoy the beautiful views of coral polyps, but be prepared to encounter unexpected and unpleasant creatures. A coral reef is not just a living colony, it's a home for thousands of diverse marine creatures. And some of them can be very dangerous for humans. Like the blue-ringed octopus, for example. This is a tiny creature that you will definitely notice thanks to the bright spots on its body, but don't touch it with your hand, as it's one of the most venomous creatures on Earth. The amount of toxic venom carried by this octopus can harm 26 people, and these people are unlikely to survive this encounter. The poison works within a few minutes, and there's no antidote in the world. What makes it even more dangerous is that the octopus's sting is painless. You probably won't even know you've been stung until the first symptoms appear: body paralysis, respiratory problems, and cardiac arrest. But even if you don't notice the octopus and swim past, you'll probably notice the box jellyfish, whose tentacles can reach several feet in length. It looks like a creature from deep space, and you better not approach it. The box jellyfish is considered the world's most venomous creature. There are special cells in their tentacles that release a toxin called nematocysts. Over the past 100 years, roughly 70 people lost their lives after encountering these jellyfish. But most likely the number is much higher. We just don't know about all such cases. Unlike the painless sting of the blue-ringed octopus, the encounter with a box jellyfish hurts. Another dangerous inhabitant of coral reefs is a rock. Yes, take a look. It's just a rock that's part of the reef. But wait a minute, it seems to be moving. Don't touch it. It's incredibly venomous. By now, you've probably already realized that this is not a stone. This is the stonefish. And this sullen-looking guy is one of the most venomous fish on the planet. Do you see those little spikes along its spine? The fish raises them when it feels in danger. If the toxin covering these spikes enters your body, you have less than an hour to take the antidote. If you don't make it in time, better not dwell on the worst-case scenario. Do you still want to swim closer to the coral reef? If so, go ahead. There are other scary creatures there. This one, for example, doesn't pretend to be a rock or something harmless. It looks dangerous, and it is dangerous. It's the moray eel. These underwater snakes are not venomous, but meeting them can be unpleasant. They can bite quite painfully, but only if you disturb them in their burrows. Of course, you probably won't want to tease these creatures, but you might accidentally approach their burrow without knowing they live there and poke it with your finger. Once you do it, get ready for a payback strike. By the way, moray eels are poisonous because they eat toxic algae and fish. However, they can't use this poison against you unless you try to eat them. As you approach the coral reef, you may encounter a flying dagger. This is the needlefish, a thin, fast fish with a sharp nose and prickly needle-like teeth. It swims near the surface close to coral reefs at high speed, and then jumps out of the water and flies at a speed of 37 miles per hour. Many people have reported getting seriously injured by this guy. This one looks like barbed wire shaped like a star. Hundreds of sharp needles cover the crown of thorns starfish's body, and you'd better not touch them. Each thorn on their body contains dangerous toxins that cause pain, nausea, swelling, and can even lead to anaphylactic shock. Coral reefs are not just a place for them to hang out, but also food. This starfish bulges out its stomach, covers the reef surface with it, and absorbs nutrients from it. It's like something straight out of a sci-fi horror movie. But don't think that corals are something scary and dangerous. In fact, coral reefs are some of the most useful things in the ocean. They even save people's lives. Do you know that lines of coral reefs cushion the impact of tsunamis and protect the shores from flooding? Some large reefs, like the Great Barrier Reef, are the boundary between the open sea and shallow waters. They stretch along the coast and form a protective wall that serves as a barrier against tsunamis and landslides. During a storm, rocky coral reefs disperse large waves and soften their impacts on the shore. But the coolest thing is that corals help your Instagram profile look better. What? Yes, that's right. Do you know these beautiful paradise-style photos when the water near the shore is blue and the sand on the beach is white? So sand gets this unique color thanks to corals. As you already know, coral bodies are made up of calcium carbonate. When waves and storms destroy corals, they wash out these calcium particles directly onto the shore. Besides corals, tiny bits of crushed seashells also end up there. Over time, layer by layer, they build up to form white sandy beaches. By the way, parrotfish are also involved in creating this beauty. These little fish feed on algae that stick to coral reefs, so they also consume pieces of coral along with their food. Then, when they're full, they release the coral particles, which eventually become the white sand. One such fish releases about 200 pounds of coral waste per year. So in a sense, this white sand appears because parrotfish go number 2. Coral reefs are ancient. The average reef grows at a rate of about 0.7 inches per year. And now look at their sizes. The Great Barrier Reef stretches for more than 1,430 miles, and it's been growing for 8,000 years. It's been here since people began to develop agriculture, domesticate animals, and build the first settlements. And some reefs are much, much older. That's why it's so important to preserve this unique natural wonder. And humans end up destroying it, often when ships accidentally crash into coral reefs. When this happens, it ruins the home for thousands of sea creatures. Ocean ecosystems get majorly impacted. But we also try to improve the situation. Coast guards protect the areas where coral reefs grow so that no vessel can approach them. These majestic creatures are a crucial part of nature, and this is another equally important reason why we should stay away from them.
Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So, the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixers to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh? Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
If there were cataclysms on Earth every 5 minutes, living conditions on our planet would be almost the same as 4.5 billion years ago. Back then, seas and oceans boiled, lightning struck everywhere, tectonic plates changed their shape, lava flowed from volcanoes, and worse, no internet. The Earth resembled a vast boiling cauldron where life was gradually being created. If it starts to boil again, this cauldron could destroy almost all life on the planet. Consecutive cataclysms. Won't hurt to pretend. Let's imagine, shall we? Good morning! You wake up in a small underground bunker. The seismic sensor indicates that a 7-point earthquake will start in a few minutes. You pack a huge waterproof backpack and go upstairs. The underground bunker is protected from seismic activity. It moves with the ground, so you're safe here. But you need to leave the shelter because supplies are low. Also, yesterday, you picked up a radio signal telling all survivors to go south immediately. The coordinates they gave aren't far from your location. You have to hurry though before the landscape changes again. You open the hatch and find yourself in the middle of the desert. The sun is almost invisible beyond the gray sky. The ground is shaking, but you're not afraid. There are no houses or buildings, nothing to fall on you. You keep your balance perfectly, and the earthquake doesn't knock you off your feet. It's like jumping on a trampoline. The only danger is the deep chasms in the ground, but you can easily jump over them. After such an extreme morning warm-up, you decide to have breakfast. You take a tin can out of your backpack. You have a few minutes before the next disaster, so you eat and remember how your great-grandfather told you how all this started. Before all of this, the planet was divided into territories called countries. Millions of people lived in them, and then something terrible happened. The tectonic plates started to move, and the air temperature and atmospheric pressure began to rapidly change. In one day, earthquakes destroyed entire cities. Tsunamis and floods washed away the remaining ruins. Volcanic ash blocked the passage of sunlight. Forest fires destroyed almost all vegetation, and eruptions poisoned the air. Only a few people managed to adapt to such harsh conditions, and you are a lucky duck to be one of them. As you finish your breakfast, you're distracted by another ground tremor. Time to move on. Many people travel around the world alone, as they consider it a safer way of life. Some people form small communes, but no one ever stays in one place for too long. Your whole life is in motion, but you don't panic. One of the main rules during natural disasters is to remain calm, so all survivors have steel nerves and excellent physical training. You run a few miles south and suddenly smell something strange. You put on a gas mask. The earthquake has created a limnic eruption. Natural carbon dioxide is released from the ground to the surface. You feel comfortable in a gas mask, but can't run fast while wearing it. Far up ahead, you see a green forest, a rare place that was not affected by fires. You take off the gas mask and go to the tree to take shelter in the shade from the scorching sun. This green area is rich in vegetation. Colorful flowers, strawberries, and many other berries grow here. But you're concerned. Such fertile land comes from being near volcanoes. It spews underground magma rich in vitamins and minerals, so vegetation grows. You can see a high mountain in the distance. This is the volcano. An underground push occurs again and provokes an eruption. You gather strawberries and run away from this place as far as possible. Lava pours from the volcano's mouth and makes a fire in the forest. You unhook a folding scooter with a motor from your backpack and drive away from the fiery mountain as fast as you can. The sky is covered with volcanic ash, but this is not for long. A strong wind grows with each passing second. You realize a hurricane is moving in your direction. You take out a small shovel and dig a hole in the ground. The soil is dry, but you have enough strength to dig a small ravine in a couple of minutes. You dive into the shelter and cover yourself with a protective tent. The hurricane blows the volcanic ash in different directions, and the air becomes clear again. But the fire doesn't stop. The wind spreads through the forest. You get out of the ravine and put on the gas mask again. There's a lot of smoke around, and it's unbearably hot. You know the hurricane couldn't just appear without any reason. Hurricanes are formed when warm, moist air collides with the sea surface and rises to the sky, so there's water nearby. Great, because you're thirsty and want to cool down. A loud sound erupts behind you. You turn around. A massive wave of water approaches the fire. Without panic, you take your life jacket out of your backpack, remove your gas mask, and put on a diving mask and fins. The wave blows you off your feet, but you don't drown. Over the years of survival, you have learned to swim very well. You grab a passing tree and wait patiently for the flood to be replaced by another natural disaster. For 5 minutes, you sail under a black, stormy sky that sparkles with lightning. Despite the waves, you try to row south. It's getting pretty cold. You finally see the shore, but this is not a land, but ice. A strong wind brought a cold cyclone, which caused a fast temperature change. It's like you're in Antarctica. Snow and blizzards are all around. It's freezing, but you take out a thin space blanket made from foil and walk slowly south. Under your clothes, you put crumpled paper, bubble wrap, pieces of cotton. All this also helps to warm your body. Along the way, you collect several bottles of snow to melt later. Icicles form on your face, and you can't see because of the snowstorm. Suddenly, the snow begins to squish under your feet. The ice melts and turns into water. A hot stream of air blows into your face. You find yourself on hard, dry ground, looking up at the sky, then at your watch. 5 minutes pass, and the sky is again covered with black clouds. You take a metal plate out of your backpack and cover your head with it. A few seconds later, you are hit by heavy rain and hail. Giant balls of ice knock on the metal shield, but you go calmly and even with a smile on your face. The ground becomes wet and loose from icy rocks. When the hail ends, you pull out all the heat-insulating materials from under your clothes and hide them in your backpack. Then you lay out a few long spokes of steel. The spokes are wrapped with copper wire. You connect the spokes to each other, making one long antenna. You stick it in the ground and run away. After the hail from the rain clouds, lightning strikes the ground. More precisely, it hits the lightning rod you've just built. You wait for the storm to end, then take the lightning rod apart and return it to your backpack. An intense heat begins. You drink some melted snow and break your way through the desert. The earth trembles, and your adventure begins again. Earthquakes, carbon dioxide, fires, floods, snowfall, tsunamis, lightning, and again and again and again. With the help of a compass, you continue your journey and reach your goal a few months later. You see a long antenna sticking out of the ground. This is a place mark for entering an underground city. The city is built from dozens of massive bunkers connected to each other by tunnels. The city walls don't allow radiation to pass through, and they don't bend from daily earthquakes. People learn to extract energy from the ground. The Earth's core gives heat. This heat boils water, then steam is formed, and electricity is created at special stations. People get water from underground lakes and rivers. Instead of the sun, ultraviolet lamps are installed everywhere, which provide people and plants with necessary light. Natural disasters happen on Earth every 5 minutes, but humanity still has a lot of space underground. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us. Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those. Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not far away in space terms means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems, those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years, There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today. Across countries like France, Australia, and the United States, homes are starting to lose their shape. Walls crack and foundations move. Millions of homes are at risk, and yours might be next. The cause isn't earthquakes. The ground itself is shifting. It often starts small, a thin crack on a living room wall. But over time, that line spreads, grows wider, and becomes hard to ignore. Across Australia, more and more homes are starting to show such cracks. All because a long, record-breaking drought is drying out the ground beneath them. And when soil loses moisture, it shrinks. As a result, the foundations of a house can shift unevenly, which puts a lot of stress on the structure. Walls begin to move, and cracks appear. Now, some types of soil make the problem even worse, especially clay. It reacts a lot to water. When it rains, clay soil soaks up the water and swells. When it dries out, it shrinks, kind of like a sponge. The problem is, many areas haven't had much rain for months, and in some places, almost a year. So the soil is drying out way more than it normally would. Recent data shows how extreme the situation has become. Australia experienced one of the hottest and driest years on record. Soil moisture levels have dropped way below average across most of the country. In some parts of New South Wales, especially along the east coast, conditions have worsened quickly. By December, around 48% of the state had soil moisture levels far below average, up from 25% just 1 month earlier. At the same time, plants and trees are trying to survive by pulling even more water from the ground, drying the soil out further and speeding up the process. The result is a vicious cycle. The ground keeps shrinking and foundations keep shifting. Many homeowners, especially around Sydney, spot new cracks or notice old ones grow worse, sometimes in just a few weeks. Moving on to France, more than half of its mainland territory, about 55%, is now classified as being at medium or high risk of house cracking caused by clay soil movement. That's up from 48% in 2020, and it affects more than 12 million homes. Homes built since the 1970s are more at risk because, back then, builders used smaller and shallower foundations. These foundations don't cope well when the ground starts to move. That's why newer rules, introduced in 2024, now require stronger foundations. They have better chances to properly protect homes. A severe drought in 2023, followed by extreme heat, led to a sharp rise in cracks. In some cases, areas can be officially declared natural disaster zones. It allows homeowners to get insurance support for repairs. But it's not that simple. Claims for damage caused by clay soil come with a higher excess, about $1,800, compared with $450 for other types of damage. And proving the damage isn't always easy. One house may crack while the one next door stays fine, which makes it harder to connect the problem directly to weather conditions. Now let's see what's happening in the USA. Carol Devon first thought that her suburban St. Louis home was just settling when small cracks appeared in the walls. But when large gaps opened between her fireplace and the ceiling, and her family room began to tilt, she realized the problem was far more serious. Scott Noche, a 48-year-old physical therapist in Lee's Summit, Missouri, is installing 33 piers, each costing around $1,000 at his two-story home. With added costs for rebuilding the driveway, sidewalks, and landscaping, his total repair bill is expected to reach about $50,000. He first noticed problems last summer when drywall started cracking and doors began sticking. But the situation got even worse during a drought. His back deck sank by about 10 inches, and inside the house, rooms began to tilt, some by up to 4 inches, making movement difficult. Nearly every home on his street has needed similar repairs in recent years. Across the United States, thousands of homeowners are facing the same situation. Movements of soil crack foundations, damage basements, and spread upward into walls and structures. In some areas, gaps wide enough to fit a hand are forming around houses. In many cases, repairs cost tens of thousands of dollars and can even exceed $100,000, often without insurance coverage. In any case, insurance rarely helps. Most policies cover sudden events like fires or floods, not slow ground movement caused by drought. In many cases, claims for this type of damage are denied. Repair companies are struggling to keep up. Cases have been reported in about 40 of the 48 contiguous states, and total damage could go over $1 billion. Cities like St. Louis, where many homes were built with heavy brick structures, experience more damage because brick houses put more weight on foundations than lighter wood or siding homes. This increases strain when the ground moves. Fixing the damage is expensive because it's not just patching cracks. In many cases, contractors must install steel piers under the house to stabilize it. They drive such piers deep into the ground, sometimes down to bedrock, using hydraulic equipment, and the process is very costly. The main thing here is prevention. Homeowners should watch for gaps forming in the soil near foundations, and, if possible, keep the ground evenly moist. Some also use mulch around the house to slow water loss from the soil. The thing is, cracks in walls can look worrying, but in many cases, they don't mean that your house is falling apart. If the soil your house is built on shrinks and swells, depending on the amount of moisture, these cracks might come and go with the seasons. They're likely non-structural, meaning they do not usually affect the safety of the house and its inhabitants. To understand the problem better, you should first check what type of soil your house is built on. You can ask local councils or request geotechnical reports from building permits. They might give you this information. There are ways to reduce the movement of your house, but most are easier to apply during construction. For example, stronger foundations can help, but they're expensive and not always practical for already existing homes. Once cracking has started, it is difficult to fully stop it. You can only control how much moisture the soil around the house gets. Some people try removing trees near the house, since roots can draw water from the soil. But this can actually backfire. Cutting trees can suddenly change moisture levels in the ground and make the soil even more unstable. Another way is to build a barrier around the house, like a concrete strip or paved area. This pushes the wet and dry zones away from the walls and helps reduce soil movement right under the house. Watering lawns is also tricky. Too little water dries the soil too much, but too much water can create uneven moisture around the house and cause more movement instead of less. So, as you see, there is no simple fix. Experts recommend getting a professional assessment before taking action. An independent structural engineer or building consultant can help identify whether cracks are harmless or part of a bigger problem. Over the past century, human activity has trapped more heat in the Earth's atmosphere. This extra heat is changing the planet's climate, and scientists say Earth is now holding more energy than it releases. Because of this, the weather is becoming more extreme, with terrible storms and droughts. In some places, strong snowstorms block roads and disrupt transport. In the United States, tornado seasons are becoming more intense than expected. In other regions, heavy rain causes flash floods and serious damage. The year 2025 was one of the hottest years ever recorded. Most of this extra heat doesn't stay in the air. It goes into the oceans instead. About 91% of it is absorbed by the sea, which is warming ocean water and disturbing marine life. Scientists warn that if this continues,